them and subtract them, what do you have to remember to do? Line them up. Line them up. Remember, you can add zeros to fill in to make the columns straight, just to make it easier, because as you add zeros to the end of a number after the decimal point, you don't change the value of the number. You can add as many zeros as you want, and you don't change the value of that number. When you multiply them, what do you have to remember? Count how many decimal places you have in the problem. Make sure you have the same number of decimal places in your answer, because that takes care of the denominator. When you multiply just the numbers as if they were whole numbers, you are multiplying the numerators, remembering that decimals are fractions as well as common fractions. You just don't see the denominator because the place that they are, the place where the numbers land, give the value, gives what the denominator is. Remembering that when you see that, that's 3 what? 3/10. You see, it's not just a 3, it's 3/10. And this is 3/100. You see, it's still 3, but the place that it lands in tells us what that denominator is. And if you wanted to make it as a common fraction, you'd read it and you'd write it, and if you could, you'd reduce it. But this is the same as this is the same as that. It's just written in 2 different forms. So you have to remember that when you're working with decimals, you're still working with numerators and denominators, you just don't have to write them. When you're working with whole numbers, you're working with numerators and denominators. You know, if you just say 1, or even if you say 10, I have 10. 10 what? It could be 10 $100 bills, 10 dimes, 10 pennies, 10 whatever. So that's always just the numerator, the number of things, how many of them you have. And then if it's a whole number or if it's a decimal, the place tells us the value. If it's a common fraction, the denominator tells us the value of that number, okay? When you divide, if there is no decimal in the divisor, what do you do? There's no decimal out here, but there is a decimal in here.
Just bring the decimal up.
Just bring it up. If there is a decimal out there, and let's say there is no decimal in there, what do you have to do?
Move the decimal to the right.
As long as there's one out here, you gotta do something. You gotta move it. This has to be a whole number. This time I only had to move it once to make it a whole number. I could have that. You don't know what the number could be out there. The main thing is you gotta bring it all the way here and count. We'd have to move it 1, 2, 3, 4 times here. What would we do here?
Move it after the 5.
After the 5, we gotta move it 1, 2, 3, 4 times here. Once I move it, what do I do with it?
Move it straight up.
Put it straight up. And then you just divide normally. Okay? So that's decimals and how to perform the 4 operations on them. Let's look at the kinds of problems you might have with decimals. Turn to page 95, please. Exercise 13. Says Tito rode his bicycle for 1.5 hours at an average speed of 15 miles per hour, period. When you are doing word problems, you stop at that period and figure out what information have they just given me. Get a picture of it or draw a picture of what it says. It says he rode his bicycle for 1.5 hours. That's how long he rode it. At an average speed of 15 miles per hour. What does that mean, 15 miles per hour? What does that mean to you? But what does it say in terms of travel? If he rode his bike for 1.5 hours and it says his average speed was 15 miles per hour, that means that every hour he covered 15 miles. That's what that miles per hour means, right? Every hour he covered 15 miles. And I say that because once you understand it, it's not always about working the problem. If he did 15 miles in an hour and a half, how many miles would he go? He'd go 15 miles and half of 15 miles, wouldn't he? See, you could figure that out without having to do big math. Half of 15, 7.5, right? So he did 15 plus 7.5, he would have done 22.5 hours. But they said, how many miles did he travel? So for every mile, he had 15 miles per hour. So what are you gonna do to figure out how many miles he went in 1.5? Multiply it. So go on and do that. Multiply 15 times 1.5. Got your 22.5, right? But it's good to figure it out logically too, because you knew that it had to be that, or close to that. So if you had multiple choice, you could look at the answer choices and probably pick out that answer without even figuring it out. Or if you figured it out, then you could know that your answer was correct. Okay? Let's turn the page and look at number 2. It says a sign at a highway tunnel says height limit, and we're on page 96, is equal to 11.5 feet, period. So let's get a picture of that. You're getting ready to go through a tunnel, and it says height limit is 11.5. So if your truck is 12 feet high, is it gonna make it through that tunnel? No, you see. If it's 11.5, I'd be a little leery, as it probably to be you're right there scrubbing that roof. So you know you want your truck to be shorter than 11.5 feet if you want to make it through that tunnel. That's what that first sentence says to you. When the air is low in the tires of Mark's truck, the truck is 10.65 feet tall. Okay, we got a picture. The tires are low, the truck is lower. When the tires are full, the truck is an additional 0.2 feet high. By how much does Mark's truck clear the ceiling of the tunnel when the truck tires are full? So what do you have to do here? They want to know how much does it clear when it's full. What does it mean, does it clear? By how much? It means how much room is left, right? What operation do you have to perform to figure out how much is left? You're going to add to figure out how much, you have to subtract, right? In this case, you're going to have to add first, because you're going to have to add his full tire, the additional 0.2 feet, to the low tire. So how high is his truck when the tires are high? 10.85, not 10.67, right? If you keep that decimal point lined up, you're going to have the 2, because it's 2/10 and 6/10. That's going to give you 8/10, so 10.85. And then you're going to subtract that from 11.5, and what do you get?
0.65.
Let's see if everybody gets that. We're on number 2 on page 96. Everybody get 0.65? Brenda? Did you borrow? Did you have to borrow? You had 10.85 from 11.50, right? You had to borrow from the 5, and that's going to be 14 up there now instead of 15 to take the 8 from. Because you had to take the 5 from something. You didn't add a 0 there, so what'd you do, just bring that 5 straight down? So you gotta, and that's why I say you have to think of the words, not just the numbers. It says you gotta take 5 from something. You can't just say, well, I'm gonna just keep that 5, you gotta take the 5 from something, and when there's nothing to take the 5 from, it should cause you to pause and say, wait a minute, where am I gonna take this 5 from? You know, that's why I don't have you memorize, stick a 0 there. No, you need to think about what you're doing and say it's a subtraction problem. I have to take 5 hundredths from something. I don't have any hundredths, so I have to go get some. Okay? And I'll tell you, in multiple choice, they probably would have had both answers. They would have had that .85 and .75 you had and the .65. Because they know that people will do that. They'll just bring that 5 down and forget about it and then just subtract from the dimes. Okay, number 3. Did you get the .65?
Yeah, .65.
Okay. Number 3 says the population of capital city is 1.3 million. Okay, we got an idea of that, 1.3 million. The population of the surrounding suburbs is another 1.12 million. What is the population in millions of the entire metropolitan area of capital city and its suburbs? What do you have to do to figure that out? Add. Okay, add them up and tell me what your answer is. Okay, 2.42 million.